Okay, so now what we're going to do is we're going to keep going with this function stuff, okay? Now remember, we saw different ways of actually getting functions. You know, we saw with correspondence diagrams. We also saw with relations, graphs, and with equations in two variables, x and y. And basically with the equations, it boiled down to sketching the graph, which is a lot easier because we have Desmos, okay? And it really, you have to use the vertical line test to determine if y is a function of x. That's really what we mean by function for now, if y is a function of x. Now and the domain, remember, by definition, that's where all the inputs come from. In other words, it's all the numbers you could put into the function that give you a reasonable output. And when you're finding the domain from an equation, that can be a little tricky. I mean, I did post last time 3 rules, so to say, where you never divide by 0, you never take the square root of a negative number, and if you're dividing by a square root, you also don't want the radicand to be 0. I mean, I'm trying here in this slide, I'm posting the same thing essentially, but it's more like a procedure. For instance, if we have, say, w over g of x, right? Let's say we have that. W is just some expression in x. Usually for us, w will have domain equal to everything, you know, all numbers. Normally, you do have to worry about what the domain of w is, but for now, we're not going to worry about that. But the domain of this is all x, such that g of x, the denominator, is non-zero. Again, you never divide by 0. Okay, but how do you actually find that domain? Well, what you have to do is you determine where the denominator is 0, and those are the numbers you're going to throw away. In other words, the domain is going to be everything else. Okay. For this, if you have the square root of g of x, you know, g of x is a function. Here, you want the radicand, the g of x, you know, what you're taking the square root of, you want that to be non-negative. Okay, we want that here to be non-negative. And also, if you have this, again, w over the square root of g of x, again, normally you would have to worry about what the domain of w, but for now, let's not worry about that. But here, though, since you have the square root of g of x in the denominator, here, the domain is all x, such that the denominator g of x, such that g of x, the radicand here, is strictly greater than 0. You know, it's not like number 2 where it's greater than or equal to 0. We don't want it equal to 0, so just greater than 0. All right. And these are just some examples. I think some of these we saw last time, like y equals 1 over x. We've seen that. The domain of that is all x except 0. You know, when is the denominator 0? When x is 0. So that's the only time the denominator is 0. So we throw it away. For the square root of x, right? The square root of x, well, again, when is the radicand x alone non-negative? That occurs when x is non-negative. As an interval, the domain is this. And for this one here, the only difference is we don't allow the radicand to be 0. So in this case, we don't allow x to be 0. So the domain is all x such that x is positive. And as an interval, right, we would have this, all x greater than 0. What we're going to do now is we're going to do some examples of this. Okay, so first, we're going to find the domain of this function, okay? 1 over 4x minus 8. So the numerator is just 1, so which is defined really everywhere. But for now, let's just forget about that. So we want to know when the denominator is not 0. That's what we're looking for. When the denominator is not 0. Okay. Now, how do we do that? Well, let's first determine where it is 0. And then basically the domain will be everything else. Okay. So we have 4x minus 8 equal to 0. So what do? Well, we add 8. Again, we want to solve this equation, so we want to get x all alone. So we add 8 to both sides, as you can see. And we get 4x equals 8. But we don't want 4x, we want x. So what do we do next? We divide by 4. So we get 4x over 4 equals 8 over 4. So we get x equals 2. Hence the domain then. So x equals 2 is when the denominator is 0. So the domain is everything else. That is, the domain is all numbers except 2. That's what we get. Are there any questions on that? Okay, this is actually the graph of the function here. You know, we have f of x equals, here I wrote it as y equals, but it's really the same thing. So this is what the graph looks like. Let me actually, I did this for the other class. Let me show everyone this. Let's go to Desmos. So I'm going to stop sharing this for a bit. Let's go to Desmos. All right, so let me share the, what do you call it? Desmos, Chrome tab. There we go. I mean, if you type desmos.com, this is the site you'll be at. Excuse me. And to get to the graphing calculator, you click on Math Tools, Graphing Calculator. Okay. Now we want to graph the function, so we could use the keyboard here, down here. Although you could just type it in directly. We have y equals 1 divided by 4x minus 8. I think that's what we have. Yeah. I think that's right. Let me check. Yeah, that's right. Okay. But this is the graph you get. So this is what the graph looks like. Okay. In fact, hopefully you can see from here, if you were to click with your mouse and hold, you can drag it. If I was to graph the vertical line, x equals 2, I just type x equals 2. Get that also. All right, so as you can see, the graph is getting very close to x equals 2, but it never actually gets there. Never gets there. I mean, this is a little beyond the scope of the class, but x equals 2, we say, is a vertical asymptote. That you'll study more if you go into pre-calc. So that's a different story. But this is what the graph looks like, and that's how we get it in Desmos. I mean, on your graphing calculator, you can get it as well. You don't have to have one, though. You know, we have Desmos, thank goodness. All right. Now, let me go back to the lecture notes. Gotta be a way to show that. Oh, no. There it is. Here it comes. There it is. Okay, so that's our graph again, as we said before. So this is what we get here. This is our graph. Okay, so here's another example. Now here we have the square root of 2x plus 7. So we want to know, when is 2x plus 7 non-negative, right? We have a square root. (2x plus 7), right? Again, you can't take the square root of a negative number. So we want to know when 2x plus 7 is non-negative. So we have an inequality to solve. So just like before, we have to get x all alone, right? So we subtract 7 from both sides, and we get 2x greater than or equal to -7, right? That's what we get here. And then, right, we divide, again, we want to get x all alone. So we subtracted 7. Now we divide by 2. And what we get is x greater than or equal to -7/2, which is -3.5. Excuse me. Notice that when we divided by 2, we did not flip the inequality. We didn't do that. Okay, you only turn the inequality around when you multiply or divide by a negative number. And here, we divided by a positive. So in this case, the domain is, so here, this is non-negative only when x is greater than or equal to this, -7/2. So x is greater than or equal to -3.5. So in other words, the domain is this interval.